Hello, dear students. This is my second online lecture. And remember last time in our first online lecture, we ended up talking about the production function. And we said the highlights of what we mentioned before is that the production, in production theory, the production function displays three different stages. Two stages of those three are considered irrational. These are stages 1 and 3. In stage 1, remember, there is no economics, there is no thinking. All what you need to do is just to keep adding more of the variable input given that you have some fixed inputs. Because production, at a part of stage 1, the production level increases at an increasing rate till the inflection point, and after that, the more you add the variable input, production will keep increasing but at a decreasing rate. So there is no thinking in stage 1. This will happen all the way in stage 1. Remember, stage 1 ends when the average physical product of the variable input is at a maximum. And we know that when the average physical product of the variable input is at a maximum, the marginal physical product of the variable input is equal to average physical product of the variable input. So this is when marginal physical product of the variable input is equal to average physical product of the variable input, MPP of x1 is equal to APP of x1. This is the end of stage 1 and the beginning of stage 2. And we said that in stage 1, you have to keep adding the variable input without thinking. There is no thinking. Just keep adding the variable input. Once you will find that the additional, if you increase the level of the variable input by 1 unit, output will increase by less than 1 unit, okay, which is output increasing at a decreasing rate. And where exactly this happens at the average contribution of the single unit of the variable input, which is the APP of x1, then here this is when thinking will start. Should I start adding more units of the variable input, or should I stop? And we know that in stage 3, of course, it is irrational, because in stage 3, the more you add the variable input, output will decline. So no rational producer will ever do that. So all the economics is in stage 2. Stage 2, remember, begins when APP of the variable input is at a maximum, and we know it begins when MPP is equal to APP, and it ends when output or TPP, or level of output or total physical product, is at a maximum, which corresponds to a marginal physical product of the variable input, or MPP of x1 equal to 0. All the economics is within stage 2. What is very important is that you will never use the level of the variable input at the beginning of stage 2 or at the end of stage 2. This is excluded. It never happens. But the level of the variable input that will make the producer maximizes his or her net returns is somewhere in stage 2, somewhere between the two borders of stage 2. Of course, there are more explanations detailed about that depending on the level of economics that you study. There is a long story here that tells you why and why not, because as I told you in my classes all the time, there is nothing as such as this is it. This is what the theory says, and you have to swallow it and accept it as it is. This is not true, but there is a long story here that I do not want to go through, given the level of economics that you are studying. Whether you are, for example, studying some introductory economics in the first level, or some introductory to intermediate economics in the third level or up. There is no need to go beyond that, but the most important part is that all the economics, all the thinking is within stage 2 of production, never on the borders of stage 2. It is always inside that stage 2. The question is how much of the variable input I'm gonna utilize given that I wanted to maximize my net returns. And the answer for that is where exactly in stage 2 I should use x1. It depends, or the variable input, it depends on the unit price of the variable input, which is P of x1, and the unit price of output, which is P of y. And this is what we will see right now. This is the shape of the production function and the average physical product of the variable input and the marginal physical product of the variable input. And these are the nodes now. These are the three stages. But now we are introducing money to our story. Remember before we were talking about how much of the variable input the producer should add in order for him or her to maximize his or her net returns. But remember, the story that we mentioned so far did not include any money. There was no money in the story. This tells you how much you should use of x1 regardless of money, which means that assuming that you are receiving x1 for free and you are selling output for free. Now, of course, we know that in reality this never happens. And we will pay money for the inputs that we use and we receive money for the outputs that we sell. So here we are introducing money to the problem. So here we said that we will assume that the unit price of output, or P of y, is equal to 2 pounds per unit, and the unit price of the variable input is 12 pounds per unit. And please do not have that question in your mind, because I know that most of you or a lot of you will have it. You say, how come I am using an input that is so expensive and I'm selling and producing an output that is so cheap? Okay, remember, revenues are total revenue, as we know, it is P of y times y, which is the unit price of output times the amount produced of output. And the variable input, the variable cost, sorry, is P of, assuming that I have only one variable input, it will be P of x1 times x1. So the point is that probably the unit price I produce, when I use some little units of the variable input, I produce a lot of output, and as a result, P of y times y might be way bigger than P of x1 times x1. So do not be fooled by that. Remember, let us talk about an input such as micronutrients. Micronutrients that are used in agriculture, for example, are very expensive. But the question is, do we use a lot of it or very little of it? Okay? Let us talk about yourself using vitamins. Good vitamins are expensive. But the question is, how many pills do you take per day or per week or per month? So do not be fooled by seeing a unit price of the variable input expensive and unit price of output is cheap, because what matters is P of y times y, which is total revenue, and P of x1 times x1, which is total variable cost. This is the most, because you want the difference between both to be the highest. If the difference between total revenue and total variable cost is the highest, then your net returns or net revenues or net receipts are maximized. So we now will take that for given, and another name for the unit price of the variable input is called the marginal factor cost. Okay, another name for that is marginal factor cost. So marginal factor cost, this one is exactly the same as unit price of the variable input. It is the same. Which means that, why we call it marginal factor cost? Because it talks about the addition to total factor cost, or total variable cost in that case, when you increase the level of the variable input by 1 unit. So it is the same thing. When I increase the level of the variable input by 1 unit, it means that I'm going to buy 1 extra unit of the variable input, which is simply I'm going to pay its unit price. If I bought, for example, a bag of fertilizer that is priced at 12 pounds, 12 pounds, it means that if I buy this extra bag, then I'm going to pay 12 pounds to the entity that sells that fertilizer. So as it says here, as you can see, marginal factor cost of x1 is the same as the unit price of X1. Please keep in your mind that unit price of output is always 2 and the unit price of the variable input is always 12. And remember, on what basis do we have that unit price of output? How the unit price of output is determined here to be 2? It is the supply of output and the demand of output intersected at an equilibrium price of 2. And the same thing applies to the input market. The supply of the variable input and the demand of the variable input resulted in an equilibrium price of the variable input of 12 pounds a unit. Because in our analysis, remember, we assume that outputs are produced and sold in a perfectly competitive market and inputs are produced and sold in a perfectly competitive market. And I think I told you the characteristics for that market, that we have large number of buyers and sellers. No buyer, no individual buyer, no individual seller can control the price or control the amount of production or control the amount of consumption. We have homogeneous products, which I said that once your product goes to the market, you cannot tell that this is my product. Remember tomatoes, once it goes to the market, for example, I cannot say this is the farmer itself that produces it. He cannot come and say this is my product. And we have equal access to information. Remember, in the perfectly competitive market, we have information transparency, which means that people can know whatever they want to know as long as they want to know the information. Information is provided, actually, if you look at for agriculture, for example, information are provided to farmers free of charge. And even if you are talking about Egyptian farmers, for example, who do not have access to internet or something like that, they can ask their neighbors. And the neighbors can know that from anywhere because they can tell you what is happening in the market. It's not a big deal. Also, the fourth characteristic of that market is that if you want to become a producer, you are welcome. If you do not want to quit production, you are welcome. Nobody cares because you are one out of millions. These are the four main characteristics of operating in a perfectly competitive market. And we are assuming that in our work. Now we are going to jump to our next slides, but remember also all the time that P of Y is 2 pounds a unit and the P of X1 is 12 pounds a unit. And the marginal factor cost is the same as the unit price of the variable. Now I developed a table out of the first table that we saw before. Okay, remember we saw a table before. Out of the first table, remember this is the same X1 that we had before. Okay, and this is, as you can see, marginal factor cost, which is the unit price of X1. Remember I said that it is constant and fixed at 12 pounds a unit. Somebody will tell me how come that whether I buy 0x1, the unit price of it is 12. If I buy 1 unit, the unit price is 12. If I buy 2 units, the unit price is 12. If I buy 10 units, the unit price is 12. And the answer for that this is the market price for the variable input. Which means that, remember, we are doing short-run analysis. In the short run, the unit price of anything, input or output, is constant, is fixed. It needs time to change. I know that if we demand a lot of the variable input, the price eventually will go up. But this is in the long run, not in the short run. Remember, you can buy right now as much fertilizers as you want. Okay? Don't ever believe that the more you do that now, the price will change. Okay? But if producers collectively went for buying fertilizers more and more and more, in the long run, the price will go up. Okay? So here we assume that we have a market price for the variable input, and that market price is set at 12 pounds a unit, which doesn't change in the short run, whether you are buying a lot of X1 or are buying a little of X1. Anyway, even if you buy zero amount of X1, it still has a market price that is equal to 12. And that's why this column is constant all the way and set at 12. Now, total value product here, or TVP, it is another name for total revenue. Remember, we studied total revenue before. We said total revenue is, if I am producing one output only, my total revenue is the unit price of output multiplied by the amount produced of output. So it is TPP, this is Y, or total output, or amount of production, or total amount of production, or total product or total physical product, all that is the same. If you multiply the level of output by the unit price of output, then you get here total revenues or total receipts or total returns or total value product, and all of the four are the same. Just like my pasta example that I use all the time in my classes. Remember, I tell you spaghetti, cannelloni, fettuccine, lasagna, all that is pasta. Yeah, different names, but believe me, it is the same ingredients, which is pasta. So total value product, or total revenues, or total receipts, or total returns, all that is the same. And it is, remember, if you look at the table that we introduced before in our online lecture 1, the table was right before that. How did we obtain that column called the TVP? We obtained that column by multiplying the unit price of output. Remember, it was 2 in the previous slide. It was 2 pounds a unit. We multiplied by the amount of output which was in the previous table that we saw before. So 2 times 0, total value product here, 2 times 0 is 0 because total output was 0 at the beginning. Remember, in our example, we assumed that if I use 0x1, I'm going to get 0 output. So 0 output multiplied by 2, it is 0. And then after that, it was 12. If you look at the previous table, the table where you have total physical product on it, look at the column that was called the total physical product or level of output. Now I'm going to multiply 2 times 12, it's 24. And then after that, 2 times 30 is 60. And the story continues down all the way till you get these numbers. Okay? Average value product here is you divide total value product by the level of the variable input. Average value product tells you the contribution of the single unit of the variable input x1 to your total revenue. How much the single unit of your variable input x1 contributes to your total revenue. So here, remember here, it is obtained by dividing total value product or total revenue or total receipts or total returns by the amount of x1 used, which is the variable input. So here 0 divided by 0, 0 divided by 0, as you can see, it's undefined because it doesn't have a number. And after that, you divide that total value product all the way by x1 and you get these numbers right here. So for example, this number, let us say, what is 29.3? I want to explain the meaning of that. It means that the single unit of the variable input contributes by 29.3 pounds of total revenue. This is the contribution of the single unit of the variable input to my total revenue, given that I am using 3, if I use 3 units of the variable input. Suppose that I used 8 units of the variable input. What is the average contribution of the single unit of x1 in terms of total revenue? In that case, it will be 18 pounds 0.5. This is for the numbers that are of average value product of the variable input. Remember, we say here average value product of the variable input, but here we say total value product. It is not of the variable input, it is of output. Okay, total value product, this is for output, but average value product, this is for the variable input. And the same thing applies to marginal value product. It is marginal value product of the variable input. Okay, so here average value product of the variable input, marginal value product of the variable input, total value product, this is for output, not for input. What is marginal value product? Again, it is the delta total value product divided by delta x1, or the rate of change of total revenues with respect to x1. What will happen to total revenues or total value product when the level of x1 goes up by 1 unit? Okay, or it is the rate of change of total value product with respect to the level of x1, or it is the first derivative of the total value product function, or it is the slope of the total value product function. These are all names that correspond to marginal value product. And by the way, in my Word documents, I have stories and stories about that. I think Shireen 7 and Shireen 8, they have stories and stories about that. But here, too bad, the only way I can make a lecture is through a PowerPoint. I cannot record my voice along with a Word document or a PDF. It has to be through a PowerPoint. I tried very much to switch my PDF or Word documents to PowerPoints, but unfortunately they are looking for money. I tried my best, but every time I keep doing and doing what I'm doing again over and over again with no result. So I'm sticking to show my lecture on a PowerPoint, unfortunately. And this is only the only thing that we received from the university, how to make a video out of a PowerPoint. So sorry for that, guys. Now, how do I get that? Remember here, it is undefined, as usual. Now, this 24, how did we get this 24? It is very simple. Remember delta TVP divided by delta X1, which will be 24 minus 0 divided by 1 minus 0. And it will be 24 here. After that, how do we get this 36? 30 minus 24, sorry, not 30 minus 24, let me erase it. Sorry. How do we get this 36? We get this 36. 60 minus 24 divided by 2 minus 1. How do we get this 28? 88 minus 60 divided by 3 minus 2 all the way till you get these numbers. And as you can see here, AVP is never 0 or negative, just like the APP. And the MVP could be 0, it could be negative, just like the MPP. Okay? How do these graphs look like if you graph them? Okay, I'm going to jump to the before I jump, because remember to making a video, you cannot go back to the previous slide, unfortunately. Here what they will tell you later on is that if you want to use the level of X1 that will maximize your net returns or net revenue or net receipts, they will tell you that to use the level of the variable input at which MVP of the variable input is equal to MFC of the variable input. Okay, so in that case, if I want to maximize my net revenues, I should use 6 units only of the variable input. If I do that, then it means that I will maximize my net revenues. This is the result of the match. I know I spoiled it for you, but this is the result of the match. The rules tells you that use the level of the variable input at which MVP of the variable input is equal to the unit price of the variable input. And the question is, does this equality have to be identical? Yeah, 12 equal 12, and the answer is no. You look at the two closest numbers to each other. Okay, the two closest MVP of X1 to MFC of X1. But here in that example, why the author, the person who designed this PowerPoints, why did he make it like that? Just to make it easier for the student. But in reality, it is never like that. You look at the two closest numbers along the MVP of X1 and MFC of X1. This one is constant all the way. Which number here in the MVP column is the closest to the 12? And then you go to the left. And sometimes, remember, also in reality, you can say that the profit, the net returns maximizing level of output is somewhere between 5 and 6 or 6 and 7. It happens also, okay, in reality. But here in that example, because it is a simple example, here if you want to maximize your net returns, then in that case, you should use 6 units of X1, because if you do that, remember, I told you that in stage 2, okay, it is the rational stage, it is the economic stage, it is the stage where you do the thinking, it is the stage where you will decide how much of X1 you will use if you want to maximize your net returns. And I told you it is never on the borders, never at the beginning of stage 2, never at the end of stage 2, and it depends on the unit price of the variable input and the unit price of output. Okay? Another way of writing that condition, I told you use the level of X1 at which MVP of X1 is equal to the unit price of X1. It is also the same as saying use the level of X1 at which the MEPP of X1 is equal to P of X1 divided by P of Y, which means use the level of X1 at which the marginal physical product of X1 is equal to the price ratio between input, the variable input and output. Okay, now I'm going to use to the next slide. And as you can see here, the graph here for that thing. AED here actually it's not AED, it is pounds. AED it means Arab Emirates dirham because this one was made over there. But just forget about AED, it is pounds. Okay. Here I put money, which is pounds or dollars or sterling or dirhams or whatever, and here I put the level of x1 that I use, given, remember, I have, this is the variable input x1, given that I have fixed inputs x2 all the way to xn. Okay. Surprisingly, it's not surprising, actually it is common sense, okay, that the shape of this is the blue line is the total value product or total revenue function, which exactly looks like the production function. Average value product, which is the pink line, okay, exactly looks like average physical product function. The yellow line, which is marginal value product of the variable input, looks exactly, which is the yellow line, looks exactly like the marginal physical product of the variable input. And why do I say common sense? Because total value product is a function, average value product is a function, marginal value product is another function. Of course, all of them are not the same f. And if I want to use the names, it will be, I can say that total value product is a function of the level of output. Average value product is a function of the level of the variable input, and marginal physical product is a function, another function of the level of the variable input. When you multiply a function by a constant, okay, then you obtain the same shape. The function doesn't change. Because here, what varies here is only the unit of measurement that we are using here. That's the only thing that you do. All these things here are measured in monetary units. All these are in money units. And that's why I can measure them all vertically, as you can see here. Now I have here, that's why they take the same shape, because they are functions multiplied by a constant or divided by a constant. It doesn't matter. Okay? Or they are measuring rate of change of the total function with respect to a change in the level of the variable input, such as MVP. Here I have marginal fixed cost, marginal factor cost. This is a green line that goes horizontally like that to tell you that whether you are buying 0 units of the variable input or 1 unit of the variable input or 2 units of the variable input or 10 units, okay, anyway, Habib Albi, you will do that by receiving, you will be paying $12 a unit. That's why here it is like that. Now given that graph, okay, the intersection point, which is right here, okay, between the marginal factor cost, which is in green, and the marginal value product, which is in yellow, tells you that if you use 6 units of the variable input, you will maximize your net returns. This is how to show that graphically. Now I'm going to jump to the next slide. Okay, and this is what I mentioned to you before: total revenue, or total receipts, or total value product. Total revenues, total receipts, total returns, total value product, all that is the same. It is equal to the unit price of output multiplied by the amount produced of output or amount sold of output. Here we assume, by the way, in our analysis that what is produced is sold already. There is no storage of anything, just to make things easier. Okay, total variable cost, which is TVC of X1, will be equal to the unit price of X1 or marginal factor cost of X1 times the amount used of X1. Net revenues or net receipts or net returns or net value product, if you want to call it. Here the best thing we use NR just to make it easy. It is total revenue minus total variable cost. This is the thing I want to maximize. Okay. Here the optimality rule tells you that use the level of X1, okay, where the NR is the highest. Okay. So it tells you that use the level of X1 when the marginal value product of X1 is equal to the unit price of X1, or alternatively, use the level of X1 at which MEPP of X1 is equal to P of X1 divided by P of 1. It is the same thing. This is the optimality rule. Now here in this table, he wants to prove to you that the optimality rule is correct. And really, if you use the level of X1 at which the marginal value product of X1 is equal to marginal factor cost of X1, you will maximize your net returns. Here he's making you to calculate. Okay, in this example, this is the same column that is called X1, and this is the same column that is called total value product or total revenues. And this is he made a calculation of the total variable cost. In this column here, we are multiplying, in this column, we are multiplying the P of X1 multiplied by X1. And the numbers here, remember here we have it is in money. This one is in money, this one is in money, and this one is in money, in pounds, yeah. Okay, so this is the calculation of total variable cost. Now, subtract the total variable cost from total revenue. 0 minus 0 equal to 0. 24 minus 12 equal 12. 60 minus 24 equal 36, and so on. Now you have, this is the highest thing that you got. Somebody will tell me, doctor, but also this one is equally high. Why haven't I said that I should use 5 units only of X1 to maximize my net returns? And the answer is because 6, this is where the rule applies. Okay, remember here it means that, but remember here we are using a very simple naive example and the functions that we graph are actually not continuous functions, they are discrete functions, broken lines connected together. And as I told you, in reality, you will never see a marginal value product of the variable input exactly equal to the marginal factor cost or unit price of the variable input. It will never happen. So here, the reason I'm choosing 6, because this is what will result in maximizing my net revenues. Remember here in this example, coincidentally using 5 or 6 units of the variable input results in the same net revenue, but actually you should use 6 because this is, despite that you have 2 choices, this is the choice that you should take and claim that I should use 6 units of the variable input to, if I want to maximize my net returns. Of course, there are long stories behind all what I'm saying, but given the circumstances that we are living in, given that I cannot see you, I cannot show you things more than what I cannot use anything more than the PowerPoint I'm showing you, okay? Just take it for now, and believe me that I should use 6 units of the variable input because this is the one that will maximize my net revenues. Despite that, using 5 units of the variable input result in the same value, because right here at 6, we saw that graphically in the previous slide. This is where the marginal value product of the variable input is exactly equal to marginal factor cost. Now I'm going to jump to the slide next to it. Now, remember I said that in the long run, remember we said that all our analysis in the short run, which means that the unit price of X1, which is P of X1, is assumed to be constant in the short run, and the unit price of output is assumed to be constant in the short run. The question is, what will happen if, remember I told you that in stage 2, how much you should use of X1 to maximize your net returns or net revenues depends on the unit price of the variable input and the unit price of output. So the question is, what if the unit price of the variable input changed? What if the unit price of output changed? And what if both changed? Luckily for you, because we are doing comparative static analysis, we are going to assume only a case of a change in the variable input only, the unit price of the variable input only, and a case of it and holding everything else constant, which is ceteris paribus, or we are going to assume that the unit price of output changes ceteris paribus, which means that everything else remains the same. In that case, you have homework about what will happen if the P of X1 changes, everything else remains the same, or P of Y changes, everything else remains the same. Please try to do that because you will learn a lot. Okay? But what is the story and why the optimality rule? This is not introductory economics. This is a little of advanced economics or intermediate economics written in an introductory way. Okay? Because here, remember, what is the moral of the story? Okay, here that he's trying to tell you here. Okay, he tells you that, remember when I talked about demand theory, and I will talk about that more often. I'm gonna talk about demand functions. I'm gonna talk about demand functions for the people who are studying economics of food processing. Okay, and we'll talk about demand shifts. But remember, we talked about that already in the first semester of when you guys were in the first level. I know that you forgot already all that, but for the people who are, because this lecture is combined economics of food processing and the principles of agricultural economics. I will talk more to the economics about demand functions to the students who are studying economics of food processing. But since that for the students who are taking the course with me who just finished that last semester, hopefully they remember that. Remember, people who are studying economics of food processing are already in the third level. You guys in the studying 03102, which is principles of ag economics, just finished demand functions a semester ago. So I hope that you still remember it. Okay, what is the story here? The story here, they tell you that the part, let me tell you the result of the match just to spoil the fun. The part of the value of marginal product, okay, that starts from maximum value of marginal product all the way down. This is the demand function for the variable input. Okay, let me repeat. The part of the VMP of X1 from the moment that it reaches its maximum all the way down. Okay, this is the demand curve for the variable input. And here, in order to prove that to you, to prove what I said to you, he said he changed the unit price of the variable input. Okay, and he made calculations about what will be the optimal amount of X1 that I should use to maximize my net revenues given the new price of P of X1. Here he made this price scenarios. He said that assuming P of X1 is equal to 4. Remember in our course, in our example in the previous slides, we assumed that P of X1 is equal to 12 pounds a unit. He said that please repeat the tables, repeat the calculations that we went through, but assuming that the unit price of X1 is 4. Everything else is the same. And then you will obtain in that case X1, optimal X1, which is X1 that maximizes your net revenues given that the unit price of X1 is 4. And then, now another thing. Repeat the calculations again, assuming that the unit price of X1 is 8. You will find a different unit of X1 that will maximize your net returns. And then, repeat, remember we calculated between 8 and 16, we calculated already the 12. Okay, assuming that the unit price of X1 is 12. Now we're going to repeat the calculations again, assuming the unit price of X1 is 16. Everything else is the same. You will find an optimal amount of X1 that is different from what we got before. And then redo the calculations, assuming that the unit price of X1 is 20. Everything else is the same. You will find a level of X1 that will maximize your net returns different from the remainder. And then assume that, redo the calculations, assuming that the unit price of X1 is 28. Okay? Remember here, which is something that I mentioned to you before. Remember when I talked about demand functions before, and I told you that why it is so important for any producer to know the demand function for his or her product. Remember, I told you that if you really can know the demand functions and the factors affecting the quantity demanded of whatever you are producing, you are almost God. Okay? Because based on that, you can predict what will happen in the future to your product, and you can tell exactly what are the variables that really affect how much will be demanded of your product. Remember the examples I used in class, that you are married to somebody, and once, let us say that you are a girl married to a man, or you are a woman married to a man, and the man is doing exactly the things that will make you happy, as if the guy is reading your mind. You will be in heaven. And the same thing for the boys. If you are a man married to a woman, and the woman is doing the things that will make you exactly as if she is reading your mind, which means you are in heaven. Okay? So knowing the demand function is very, very important, because the producer will know exactly what are the factors that are perceived as very important from the point of view of the consumer. And if you as a producer can work on these factors that are of vital importance to the consumer, then you will make a lot of money, which means maximizing your net returns. So if the point here that are of importance as a reminder of any demand function, okay, and as we'll see later on, any supply function as well. Any demand function is composed of optimal points, which means utility maximizing points, okay? Because remember, in demand theory, we talk about maximizing your utility or satisfaction or pleasure given your income constraint. Any demand function is composed of utility maximizing points, okay? Here we are talking about a demand for an input, remember. Again, the demand for that input, which is the variable input x1, is composed of the is composed of the profit now maximizing points for the producer. Because remember, we use inputs to produce outputs. Okay, if inputs do not result in producers making profit, we will never use inputs. So here, the demand curve for the variable input is composed of all the points that are called net returns maximizing points for the producers. The reason I'm saying net returns and not profit, because profit is a different story, okay? But for you, imagine that net returns is similar to profit, okay? So the demand curve for the variable input is composed of all of the points that are net revenue maximizers, which means that it tells you that you are connecting the points that maximize the net returns of the producer, okay, by knowing how much exactly you should use of the variable input when the unit price of the variable input changes. Now this is, see, okay, here that you can see this is the unit price of x1. I'm graphing here the demand curve for x1, and this is the amount used of x1. Here, these are the numbers. Remember, we used 5 price scenarios. P of x1 equal to 4, P of x1 equal to 8, P of x1 is equal to 12, P of x1 is equal to 16, and P of x1 is equal to 28. When P of x1 is equal to 4, this is if I use, as you will see, if I use 8 units of x1, I will maximize my net returns. And the same thing here. So I have these 5 points here. This is the first profit maximizing or net returns maximizing point. This is the second net returns maximizing point. This is the third net revenue maximizing point. This is the fourth net revenue maximizing points, and this is the fifth net revenue maximizing point, and this is the sixth net revenue maximizing point. Each one of them, this corresponds to, this point here corresponds to an output, a unit, P of x1 of 4. This is Px1 of 8, Px1 of, as we move up from right up to down. And this is the profit maximize. This is the level of the variable input that I should use when the unit price of the variable input is, this is 4 here, this is 8 here, this is 12 here, and then this is 16, and then this is 20, and this one, this is 28. When you connect these points, you obtain the VMP of x1, which another name for VMP of x1 is it is called the demand curve for the variable input x1. But remember, that part of the VMP curve that we saw before in our graphs, this is the part of the VMP curve that lies in the second stage of production. I know that VMP, remember, MPP becomes 0 and the negative. That part is not of importance to us in the demand curve. And also we know that we have maximum VMP. Again, this is not of importance. What is of importance is that we are talking about a story once the VMP of the variable input intersects with AVP of the variable input. This is the beginning of stage 2. Okay? Even that point is not a rational point. We have to go beyond. We have to go a little in the, because I told you that the borders of the second stage of production are not included in the rational usage of x1. So if you connect all these points, which is profit maximizing point or net returns maximizing point, this will be the demand curve of the variable input or the VMP curve within stage 2, never on the borders of stage 2. and this is the end of my class. You are supposed to do, you have a lot of homeworks that you can work on. I believe I uploaded that. In case I didn't, please let me know. And you need to practice, okay? You need to graph the tables that I gave you, okay, using the numbers that you have. You need to re-graph that table, okay? I know that the answer is already there, but you need to graph to practice to understand the story, because once you do that by yourself, you will learn much, much more than if you just look at the table, okay? And this is assumptions, the last thing that we have here. These are the assumptions. This is the last slide we have. It tells you that we assume in our analysis that the markets, okay, that we operate in are all perfectly competitive market, okay? This applies to the market for the variable input X1 and the market for output. When I say market, I mean supply of something and the demand for something, okay? What makes a market? They say that the market is the physical or virtual place where buyers meet seller to discuss an exchange of something, whether that something is a final product or an input. So here we assume perfect competition, large numbers of firms, so large that no single firm can control how much is produced or the price. Homogeneous products, we said that the products that, for example, for all farmers produce look alike. You can go out, you can come in, nobody cares. If you want to obtain a piece of information, you are welcome. Actually it is obtained almost free of charge. I am done with my class. Hopefully that I was of use to both the students in the first level studying principles of agricultural economics, or the students in the third level studying food technology and dairy sciences, because this is something basic about production theory, assuming that we have one variable input producing one output only, and assuming that we are having a number of fixed inputs as well. The story that we are trying to obtain out of all that garbage that you saw from me and received from me is that I want to know how much of X1 I should use if I want to maximize my profit, okay, which is a slang word for net revenues, which is more correct. Thank you very much. Bye.